The intent of this video is to explain how to use significant figures when performing simple calculations. There is essentially two rules to significant figures when performing sample calculations. Okay? If you are going to add or subtract two numbers, then the rule for significant figures follows the least number of decimal places. Okay. And I'm going to work some examples. But the rule, if you are multiplying or dividing two numbers together, is least number of significant figures. Okay. The only other thing that you'll have to remember when performing calculations using significant figures is that good old phrase that maybe you heard somewhere along your life before you got to this course, but some refer to it as PEMDAS. Some say, please excuse my dear Aunt Sally. And this is the order of operations, right? Mathematical order of operations. So P stands for parenthesis. So you always do the parentheses first. E stands for exponent. Then you always do the exponent second. Multiplication and division get tied together, but you always multiply and divide before you would add and subtract. So PEMDAS, or please excuse my dear Aunt Sally, the order of operations. So if you can remember those three things, the rule for SigFigs when you add and subtract, the rule for SigFigs when you multiply and divide, and the order of operations, you will be able to work sample problems. So let's do a few, and I'll look at the your turn 4.15 on page 125. So the very first part A wants you to divide 5.0 grams by 0.31 milliliters. Okay, so we just have two numbers here, and we have to remember what is the rule when we divide something. And the rule when we divide something is least number of significant figures. Okay, so we have to determine how many significant figures are in each of these numbers. How many significant figures are in this number right here? 5.0. Hopefully your answer was 2. This 5 is significant and this 0 is significant because it comes after the decimal place. It's a trailing 0 after a decimal place. We are certain that that mass is 5.0. Okay? And then if we look at this number here, how many of these digits are significant? Hopefully you again said 2. Remember, this 0 is a leading 0 and all leading zeros are not significant, but all non-zero integers are. So we've got two significant figures. We've got two significant figures and two significant figures here as well. Okay. So when we perform this division, grab your calculator and just go ahead and blatantly divide it. You don't even have to put the 0.0, honestly. You just say 5 divided by 0.31 equals. So when I hit equals, this is what I get. I get 16.129032226. And some of you, if you were performing long calculations, you'd probably use that you'd keep trying to run that entire number with you. But that's kind of the nice thing about SigFigs, is that significant figures tell you actually how certain you are about this number. If you take 5.0 grams and divide it by 0.31 milliliters, your answer is you only are sure or certain about 2 significant figures. So your answer is only going to have 2 significant figures. All the rest of these numbers, you're actually not certain at all that that's really what they are. So that's kind of where that certainty comes into play. So the true correct answer to the proper number of significant figures is 16. Okay, let's work another example. Next up is, let's do 1.003 grams plus 0.01 gram. Okay. So here I have an addition problem. Remember, there's a different rule for addition, and that rule is least decimal places. So that one, you don't even have to go through and figure out how many significant figures everything has. You just have to look at the decimal places, right? So this one has 3 and this one has 2. So we've got 3 dp for decimal place, and I've got 2 decimal places here. So when we do our final answer, if I were to add 1.003 plus 0.01, I get 1.013. Okay, but there is some amount of certainty that I only have in that number, and it has to deal with the significant figure rule. So my final answer should only be to 2 decimal places. So this number actually, I'm not certain about that's truly what that number would be. So my final answer would be 1.01 grams. Okay, so again, that followed the least number of decimal places rule. Let's try one more that I'm going to make up, and sometimes when I make ones up, oh, I get in trouble. Get in trouble. All right, let's do divided by 20.00. Okay, let's try this one. All right, so here is one that has a little bit of everything. It's got addition, it's got division, and I have some parentheses. So now I have to think about order of operations, PEMDAS. Please excuse my dear Aunt Sally. Parentheses always comes first. Okay, so remember, when I'm doing an addition, my final answer only depends on what was the least number of decimal places, which in this example, they both only have 1 decimal place. So, and I have to do my parentheses first according to order of operations. So this essentially would be 60.1, right? Because 57 plus 3, 7 plus 3 is 10, you know, so on and so forth. So 60.1, but as far as the digits go, I only need 1 decimal place here, and I need to now divide that by 20.00. So now I'm doing a division problem. So now I have to remember what the rule for significant figures was for multiplication division. And for division, it is least number of significant figures. So if I go through and I count my significant figures, for my top value up here, my 60.1, 6 and 1 are definitely significant. And remember the rule that any 0 in between non-zero integers is totally significant. So that gives me 3 significant figures for that top number. If I look at the bottom down here, my 2 is definitely significant. And now I have to figure out what's going on with all of these trailing zeros. But since there is a decimal place, and I even have more zeros to the right of that decimal place, then all of these zeros are actually significant. So I have a total of 4 significant digits there. So the rule states that the answer, it can only have the total number of significant figures in my answer can only be the lowest number of significant figures when I divide. So that'll be 3. If I were to type in 60.1 divided by 20, I don't have to put in those extra zeros, but I get 3.005. Okay, but remember, the rule is that my final answer can only have 3 significant digits, and this has 4. So I need to round. So when you see a 5 here, you normally round up, but actually the rule in science is to look 1 more decimal place to the right. In this case, I actually don't have one, but you would look 1 place to the right, and if it's odd, round down, and if it's even, round up. And that makes it, for a long story short, instead of always seeing a 5 here, rounding up, which would unfavorably always round up, it allows anything that's halfway to equally be rounded up and down based on if this is the next decimal place is even or odd. It's probably too much for this course, but in this course, we see a 5, we're just gonna round it up. So my final answer is in the correct number of significant digits is 3.01 grams. I hope that helps walk through some of the sample calculations using significant figures. Please practice by working more examples on the homework and in your book.